Just that. Can everybody hear me all right? Okay, perfect. So I only have 10 minutes, so I'm gonna just get right into it. So the thesis of my talk today is essentially the title. I hope to convince you that AI literacy, or artificial intelligence literacy, is information literacy, and that understanding AI and helping our patrons understand AI is a part of our responsibilities as information professionals. This is based on the simple presumption that AI produces, or at the very least, affects much of the information that we consume and use in our daily lives. Often, however, we do not know how an AI actually works, how it produces information and makes decisions. This is a significant issue because how can we choose to trust information when we do not understand the system that is providing us with that information? This is where we as librarians come in. Information literacy is already seen as an important aspect of librarianship, and it is our job to see that people are provided with the opportunity to obtain the tools and skills necessary to understand and evaluate the information that they encounter. Information created or curated by AI is not an exception. I believe that we already possess some of the critical foundational skills needed for AI literacy through the existing ACRL information literacy framework, particularly within the frame authority is constructed and contextual. But AI also presents new challenges that we need to develop a framework and work with other stakeholders in order to address. So now, while I'm sure everyone in the room is familiar with the concept of AI, I recognize that not everyone keeps up with the field. I just want to take a moment to define my use of artificial intelligence today. It's a more elusive concept than you might think, largely due to the fact that it's difficult to actually define what intelligence is. So, for our purposes, I'm defining artificial intelligence as any software that can complete a task we would normally assume would take human-level intelligence. I want to emphasize that my definition does not require AI to replicate how humans think, only to be able to complete the tasks that humans do. The question now is, how is this intelligence achieved? Artificial intelligence has a few different development methods throughout its history, but the most prominent method today is a process called machine learning. There are many different branches within machine learning, but the basic idea is that programs are designed to be able to learn and apply what they learn in new and novel situations. One application of machine learning is in automated decision-making programs. The purpose of an ADM is to act without human supervision or intervention and to be able to determine the most optimal decision despite being introduced to novel circumstances in different data sets. Now, today I'm going to use DeepMind's AlphaGo robot as an illustrative example. AlphaGo is an AI that beats the highest ranked human Go player in the world. Of course, AI has beat humans in the past, especially like chess, most famously the Deep Blue versus Kasparov match in 1997. Go, however, is a much more complex game. In chess, for every move, there are approximately 20 options. In Go, there are 400. The number of possible board configurations in a game of Go is more than the number of atoms in the world. This means that there isn't actually enough computer power possible in order to determine every possible outcome. Go is a game that requires not only strategy, but because it cannot be solved by brute calculation, it requires an element of intuition. This is the reason why AlphaGo is considered by many to be a milestone in AI development. AlphaGo was not explicitly pre-programmed with strategies, nor could it calculate and compare the outcomes of every move. It required a program that mimicked human intuition. AlphaGo's program developed its own strategies by analyzing 1,000 games of Go played by humans, and then refined its strategy by playing against itself using a method known as reinforcement learning. Now, besides being an impressive achievement in machine learning, the reason I chose AlphaGo as an example today is because of the strategy it used to win. Because AlphaGo developed its own strategies, neither AlphaGo's developers nor the expert Go players can actually explain the rationale for the strategy that AlphaGo used to win. Some go as far to say that they believe AlphaGo is not conceiving of the game in the same linear way that the typical human player does. Dennis Hassabis, the founder and CEO of DeepMind, described AlphaGo's style as alien. It doesn't play like a human, and it doesn't play like a program. It plays in a third, almost alien way. Now, we can take that with a grain of salt, because as founder and CEO, he has everything to gain from promoting the idea that AlphaGo has surpassed human understanding. KG, however, the world champion that was defeated by AlphaGo, and who only a few weeks earlier swore a machine would never beat him, also described AlphaGo's gameplay as godlike. I feel his game is more and more like the Go god. Really, it's brilliant. What I want to highlight is that we don't know how AlphaGo made its decisions. We can see its output, we know that it used neural networking and reinforcement learning in order to learn its strategy, but we don't actually know what it's thinking. AlphaGo functions like a black box. Information goes into a network of artificial neurons that processes the data and then delivers the commands, and we don't know what happens inside. These systems are often so complicated that even the engineers who designed it may struggle to isolate the reason for every single action. To make the situation more complicated, currently there is no obvious way to design a system that an AI uses machine learning that would be able to provide an explanation for why and how the AI made the decision. And we aren't just talking about AIs that play games either. Banks, military, and hospitals are all utilizing advanced algorithms for the purposes of automated decision-making. There's an AI called Deep Patient that is very good at predicting schizophrenia, something that is notoriously difficult for physicians. But nobody actually knows how Deep Patient does this. That's a lot of trust to put into something that you don't know the rationale for. It affects things like treatment and medication. It's a significant problem if these decisions are left inscrutable. Now, I recognize that this is a very large problem, and while librarians and other information professionals are superheroes, some of this is a bit outside of our domain. What it is inside of our domain, however, is that information is being created that people are not evaluating or thinking critically about. As information professionals, this should be something that concerns us. AI and advanced algorithms are becoming an integral part of the information landscape, and we need to make sure that people are provided with the skills and tools they need to responsibly use it. So, the problem that we should be concerned with is that we typically do not know how AI makes its decisions. I see three main reasons for this. The first is that people are not seeking out explanations for how an AI works. There are AIs that are not completely shrouded in a black box, and people could be seeking out more information about how these algorithms are making their decisions. For example, algorithms are often used to calculate credit scores. What people often don't know is how these calculations are done. Credit systems are often fed historical data to learn from, and these biases in the data shows up in the decisions. If historically a neighborhood was blacklisted for racial reasons that we now know as a society today are unacceptable, that still impacts the decision that the AI makes. This is the type of information that people can look for in order to evaluate the algorithm's credibility and ability to make decisions. This is the solution that I feel we are presently most equipped with to address using our current expertise as information literacy experts, which I will explain more in a moment. The second issue is the problem of the black box. That information and explanations as to what is happening inside of the black box are often not made available. Part of the reason is what I mentioned earlier. Developers currently do not have the know-how to design systems that could provide adequate explanations. That doesn't mean, however, that they couldn't be making the code source available for inspection. This in itself is a very complex regulatory issue, which falls into the territory of regulation and policy, so I won't say much about it today. Number 3 here refers to the issue that even if the source code is made available, however, that most of us will not be able to understand it. This is the issue that we face with AlphaGo. We cannot identify what strategy it used and why. Any kind of meaningful explanation would need to come from someone who did understand it. And if we did receive an explanation, we would be placing a lot of trust in something that may have a significant impact on our life, as is the case with the AI Deep Patient, who, if you recall, makes medical diagnoses. A proposed solution is that we need to develop an algorithm literacy and make it as fundamental as language literacy is today. So we're going to look at these a little bit more in depth. Let's start with number 1, not seeking out the information. The skills needed to avoid this pitfall already exist in the current ACRL information literacy framework. The frame, authority is construct and contextual, includes an outcome that novice learners come to respect the expertise that authority represents while remaining skeptical of the systems that have evaluated that authority and the information created by it. This is exactly what we should be encouraging people to do with AI. To understand what factors have elevated AI into a position where it is making decisions and producing information that we allow to influence our lives, and to be skeptical of those factors. There is sometimes an assumption that computers, because they calculate, provide fact, in the same way that someone in a position of authority may be blindly followed. AI are not infallible, and they are not calculating cold hard facts. They learn, and the information that they learn from, and their learning processes can cause them to make bad decisions. AI needs to be evaluated for authority just like any other creator would be. So number 2. In regards to number 2, as I mentioned, this is a regulatory issue. And while we may be valuable contributors to this conversation, it is not something we can solve through literacy skills at this time. And that brings us to number 3. How can we think critically about something that we don't understand? This is a challenging problem, and at this point, most people, when confronted with an algorithm, would need someone else to interpret it for them. Ed Finn proposes that to understand the algorithm, we need to uncover those roots and then build a new model of algorithmic reading that incorporates a deep understanding of abstraction and process. The idea is that we need to find a way to understand how AIs think and then build a model of algorithmic literacy. This model would then be taught to everyone. You would learn to read algorithms the same way that you would learn to read a book. This would require us to be able to determine how to read algorithms and then to get a lot of people to buy into a curriculum overhaul at a primary education level in order to be equitable. I'm not sure about the feasibility of this last solution, but I'm sure that we need to be addressing this issue. Information technology is advancing, and we need to be advancing with it. Thank you.